Hi, I'm Dr. G. Srinivas, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to say concept on differential equations on second and higher order with constant coefficients, and especially type 3 particular integral. So in the previous session, we have seen the particular integral evaluation by using the shorter method, that is 1 by f of d of q of x, where q of x is equal to cos bx or sin bx. The particular integral yp is equal to 1 by f of d of sin bx or cos bx, and in this case we go for a shorter method to find the particular integral. The working procedure is, first make the function f of d as a function of d square by multiplying and dividing with a suitable function, and then replace d square by minus b square, not minus b whole square, it is minus b square, if phi of minus b square not equal to 0. And suppose if phi of minus b square 0, then we see the value of 1 by d square plus b square of sin bx. Then it is minus cos x minus x by 2b cos bx. And if it is in the form 1 by d square plus b square of cos bx, then the value is x by 2b sin bx. So we are going through shorter methods to find the particular integral. So just to remember the working principle, if phi of minus b square not equal to 0, what to do? If phi of minus b square 0, what to do? If phi of minus b square not equal to 0, then just substituting d square by minus b square, you will get the required solution of yp. If is equal to 0, then you choose one of the formulas according to the given one. So now I will solve one problem. Already I have solved one problem in the previous class. Now I would like to solve this problem also and solve the differential equation d square minus 4 of y is equal to cos square x. So clearly this is an equation of linear differential equation with constant coefficient. So here f of d is d square minus 4, and the auxiliary equation is given by f of m is equal to 0, that is m square minus 4 is equal to 0, that is m minus 2 into m plus 2 is equal to 0, that is m is equal to 2 minus 2. Therefore, what is the complementary function? The roots are real and different or real and distinct. The solution complementary function c1 e power 2x plus c2 e power minus 2x. So that is the first part of the solution. Now to find, this is a complementary function. Now I need to find the particular integral. The particular integral is denoted by yp, which is 1 by d square minus 4 of cos square x. So we don't have any formula for cos square x directly to find the particular integral. So you have to express this cos square x as in terms of another function. So we know that cos square x, what is cos 2x? The cos 2x is 2 cos square x minus 1, or cos square x is equal to 1 plus cos 2x by 2. So I can write this is in the terms of 1 by d square minus 4 of cos square x can be replaced by 1 plus cos 2x by 2. If you have the function cos 2x or sin 2x or e power ax, you can substitute the shortcut methods to find the particular integral. And this is 1 by 2 constant I can write, and 1 by d square minus 4 of 1. 1 means you can write it as 1 into e power 0x also, or you can write cos 0x also, whatever convenient you can write. And the second term 1 by d square minus 4 of cos 2x. So on replacing So e power ax, this is the first model of type 1 of the finding particular integral. Just replace d by 0, d by a. If it is not equal to 0, clearly it is not equal to 0. So the value is minus 1 by 4. E power 0x is 1 already. Clearly replace d by 0. 0 minus 4, that is minus 4. So it is not equal to 0. That means what? 1 by minus 1 by 4 into e power ax. So e power ax means e power 0x. It is already 1. Now, to find the second one, replace d square by minus b square. So what you have to replace? Replace d square by minus b square. That means what? Minus 2 square. That means minus 4. If it is not equal to 0. So clearly when you replace minus 4, it is minus 4, minus 4, minus 8, not equal to 0. So I can write it as minus 1 by 8 of cos 2x. So just the application is just replace a d square by minus 2 square. Here b is 2. B square means 2 square minus sign. Minus 4 is to be replaced. So minus 4 minus 4 minus 8. So what is the particular integral? Minus 1 by 8 minus 1 by, what is this value? 8 2s are 16. Cos 2x is the particular integral or yp. Therefore, the general solution. What is the general solution? Y is equal to yc plus yp. The general solution yc plus yp. So yc is c1 e power 2x plus c2 e power minus 2x minus 1 by 8 minus 1 by 16 cos 2x, that is equal to y. So this is the general solution of the given problem. So if it is having right side as cos bx or sin bx notation, then we can apply easily. Cos square x, sin square x. You can replace it is in terms of the cos and sin functions. Thereafter, you can substitute d square by minus b square and you can find the required particular integral. So now, I would like to go for the third model, type 3 model, when the right side function is x power k notation. So now what is type 3? Finding particular integral of f of d of y is equal to q of x, where q of x is equal to x power k, where q of x is equal to x power k. So already we have seen the first one model is e power ax q of x. The second model is sin bx or cos bx. This is the second model. Now I am going to solve the problems when the q of x is on the form x power k. So how to proceed if the given function q of x is equal to x power k in shorter method? First we have to write the denominator f of d as in the form 1 plus phi of d by taking out the lowest degree term in f of d. First write in the form 1 plus phi of d by taking out the lowest degree term in the f of d. Then it will be in the form 1 by 1 plus, so first write f of d is in the form 1 plus phi of d by taking out the lowest degree term. Then yp will be 1 by 1 plus phi of d of x power k. Now write 1 plus phi of d in the numerator. So this is not right. 1 plus phi of d on the numerator, that is 1 plus phi of d whole power minus 1 of x power k. So expanding by using binomial expansions, 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube plus so on. So using this expansion, I am expanding 1 minus phi of d plus phi of d whole square plus so on, this whole of term x power k. So this term has to be expanded up to the term containing d power k. Here it is x power k. So here also we have to expand the terms up to the d power k only. Beyond that, when you operate with the d power k, those terms will become 0. Suppose if there is any d power k plus 1 term, so d square of x square. If we differentiate 2x once, on differentiating again you will get 2. And again differentiating you will get 0. So that means d square of x square will be 2 only. Then d cube of x square is equal to 0. The higher degree terms will be zeros. So we have to expand the series up to the term containing d power k only. And each term operate with x power k. That will be the now operate each term of the expansion on x power k we obtain the required particular integral. Clear? So first you write the denominator f of d as 1 plus phi of d notation by taking out the lowest degree term in f of d, and then write in the numerator part that will be in the form 1 plus phi of d whole power minus 1 of x power k. Then use the binomial theorem expansion to expand it 1 minus phi of d plus phi of d whole square plus so on. So now operate each term with x power k. That is the required procedure. On applying, you will get the sum function of x that will be the required particular integral. Now the general solution y is equal to yc plus yp. That is the required solution. Now I will show this with one example. Solve the differential equation d square minus 6d plus 9 of y is equal to x cube. So clearly, it is in the form f of d into y is equal to q of x, where q of x is in the form x power k. So as usual, find complementary function, then apply type 3 model to find the particular integral. So given equation as usual, d square minus 6d plus 9 of y is equal to x cube. F of d, right? F of d is a function of d, that is d square minus 6d plus 9. Now write the auxiliary equation. The auxiliary equation is, what is the auxiliary equation? The auxiliary equation is m square minus 6m plus 9 is equal to 0. The auxiliary equation m square minus 6m plus 9 is equal to 0. So this can be written as m minus 3 whole square is equal to 0. M square plus 9 minus 2 3s are 6m. So the roots are 3 comma 3. So clearly, it is a quadratic equation. There are two roots. The roots are real and equal also. So the complementary function is c1 plus c2x into e power 3x. This is the first part of the solution. This is common for all problems having constant coefficients. Now on going for particular integral, yp is equal to, the particular integral is given by yp is equal to 1 by d square minus 6d plus 9 of x cube. So this I can write 1 by, in the denominator I can write d minus 3 whole square and of x cube. So d minus 3 whole square in the denominator. So you have to write it is in the form of 1 plus phi of d. So how can you write? On taking out the lowest degree term outside. So 3 take outside. 1 by d minus 3 whole square. So on taking out 3 outside, what will get? 3 square. 9 will get out of the term. And this value will be 1 minus d by 3 whole square in the denominator of x cube. So here also there is a function x cube. So 1 minus d by 3 whole power 2 x cube. So that on writing in the numerator, you'll get 1 by 9. So this is 1 minus d by 3 whole square, means on writing in numerator it is power minus 2 of x cube. Now it is in the form 1 minus x whole power minus 2. So it is also binomial expansion, 1 plus 2x plus 3x square plus so on. This is the expansion of 1 minus x whole power minus 2. So this is equal to 1 by 9. On expanding here, d by 3 means x. X is d by 3. So 1 plus 2 into x d by 3 plus 3 into d by 3 whole square plus so on of x cube. 1 by 9 into, so 1 of x square. What is 1 of x? Sorry, x cube. 1 of x cube is x cube plus 2 by 3 constant d of x cube. Second term, 3 by 3 square, 9 of d square of x cube plus so on. So 1 by 9 x cube is same as x cube plus 2 by 3 into d of x cube. So d of x cube means what? D by d means differential operator, d by dx. D by dx of x cube, that is equal to 3x square. So that here I have written already d by dx of x cube, 3x square. And here 3 by 9 into d square of x cube. What is d square of x cube? So d of 3x square. And differentiating one time, 3x cube differentiation 3x square. And again differentiating d means d by dx. D by dx of 3x square. What is d by dx of 3x square? That is equal to 6x. So 6x, 3 by 9, 3 square means 9. D of x cube, d square of x cube means 6x. Already you have calculated. Plus 4 by 3 cube means 27. and d cube of x cube, d cube of x cube, d cube of x cube. That means what? We have to differentiate 3 times. First time on differentiating, you'll get 3x square. On differentiating again, you'll get 6x. Next 6. So 6 is here. That is already written here. So then 1 by 9 into x cube plus 3 cancel 2x square. 3 is 9. 3 is 9. 3 to 6. So 3 cancel 2x. So that is already written here. Plus this is what this is. 2 3s are 6. Sorry, 3 2s are 6. 3 9s 27. So then what is the value? 4 2s are 8 by 9. That is the function 1 by 9 of x cube plus 2x square plus 2x plus 8 by 9. This will be the particular integral of the given problem. Therefore, the general solution y is equal to yc plus yp. So what is yc? c1 plus c2x into, so what is the root of the equation? So I think 3 is the root of the equation. c1 plus c2x into e power 3x plus. So what is yp? Yp is 1 by 9 of x cube plus 2x square plus what is the other value? X cube plus 2x square plus 2x plus 8 by 9 plus 2x plus 8 by 9. 2x plus 8 by 9. 8 by 9 is the required general solution of the given problem. So this is the complementary function and this is particular integral. That is yc plus yp is the required general solution of the given problem. So what we have done here is just you write 1 by 1 plus phi of d whole power minus 2 or minus 1 type. Then use the binomial expansion and operate each term on x cube. Then you will get the required particular integral. So in this way, we will go to find the particular integral when the given function q of x is equal to x power k notation. So this is the third model. So first model already we have seen e power ax, e power ax or e power bx model. And second one is sin bx or cos bx. And third one is x power k. So this is the third type of the finding of particular integrals of the constant coefficients problems. So now I will do another problem just for the sake of practice. What is the problem here? D square plus d of y is equal to x square plus 2x plus 9. So I will write here the problem. So solve d square plus d of y is equal to, so 2x x square plus 2x plus 9, x square plus 2x plus 9. So this is the given problem. So we have to find the complementary function as well as particular integral. So here, what is f of d? What is f of d? D square plus d and the auxiliary equation. The auxiliary equation is in terms of m, that is f of m is equal to 0. So what is that? F of m means they replace d by m, that is m square plus m is equal to 0, or m into m plus 1 is equal to 0, or m is equal to 0 comma minus 1. So there are two roots and the two are real and distinct. Therefore, the complementary function yc is equal to c1 e power 0x, first root, and second root c2 e power minus x, or yc is equal to c1 plus c2 e power minus x. E power 0x is 1. So the complementary function yc is equal to c1 plus c2 into e power minus x. So this is the first part of the solution. Now find the particular integral. So what is yp? I can write yp or complementary particular integral is equal to 1 by d square plus d of x square plus 2x plus 9. So I can take out d in the denominator. Then you'll get 1 plus d of x square plus 2x plus 9. 1 by d on taking outside, we will get d plus 1 or 1 plus d. Or I can write it as 1 by d of 1 plus d whole power minus 1 of x square plus 2x plus 9. So what is the expansion? It is the binomial theorem expansion. 1 plus x whole power. I can write 1 plus x whole power minus x. 1 minus x plus x square minus x cube plus so on. So this is the expansion of the series. So 1 by d of the expansion 1 minus d plus d square minus d cube plus so on of x square plus 2x plus 9. That is equal to 1 by d. On multiplying with 1 by d, you can multiply or you can later also you can multiply. So now I am multiplying 1 by d inside 1 by d minus 1 by d of d 1 plus 1 by d of d square, that is d minus d cube of d. So d cube by d, what we will get? D square. So next term we will get d power 4. That we can eliminate because d power 4 by d, that is equal to d cube term. So d cube is not required. D cube of any term here is 0. So it is not required for us. Just up to this you can expand. And now apply each term on the given function. So 1 by d of x square, that is integral of this one. That is, what is the first term? X cube by 3 minus 2x plus 2x square by 2 plus 9x. First term. 1 by d of the whole term. 1 by d means integration. Integration 1 by d, you know that the particular value of 1 by d is integral of f of x dx. So on integrating x square integration x cube by 3, 2x integration 2x square by 2 plus 9 integration 9x minus 1 of this one, that is minus x square plus 2x plus 9. You will get the same terms plus d of this whole term, d of x square 2x plus d of 2x, that is 2. That is the third term minus d square of this one, d square of x square, that is 2. D square of x square, d square of 1, d of x square is 2x. Again on differentiating you will get 2. D square of x square is 2. Then what is the last term? That is the d square of 2x 0, d square of 9 0. So this is the entire function. So I will simplify this. What is yp? The yp is equal to x cube by 3. There is only one term. And 2x square by 2, that means x square minus x square. These two terms will get cancelled. And 9x plus 2x and minus 2x gets cancelled. And 2 minus 2 also gets cancelled. The value is plus 9x plus 9. This is the particular integral of the given problem. Therefore, the general solution y is equal to yc plus yp, the complementary function, and plus particular integral. Particular integral is x square plus x cube by 3 plus 2x, 9x, 9x plus 9. So this plus 9 or minus 9? This is minus 9, sorry. X cube by 3 plus 9x minus 9 will be the required particular integral, and yc, that is the general solution of the given problem. I hope this is clear, that methodology. So if you want, I can do another problem also. The problem is a d cube. So I will write one more problem. The last problem I will do. I'm going to solve the problem number 4. So what is the problem? D cube. Problem number 4. D cube. D cube. D cube minus d square minus 6d of y is equal to x square plus 1. So clearly this is also a linear differential equation of higher order with constant coefficients. The same f of d into y is equal to q of x model. And here, what is f of d? What is f of d? D cube minus d square minus 6d. And what is q of x? Q of x is the right hand function, that is x power k model. X power k plus 1. 1 you can write it as x power 0 also. 1 I can represent x power 0, or you can write e power 0 or cos 0. You can use any model for the constant. So now the auxiliary equation is, what is the auxiliary equation? The auxiliary equation is f of m is equal to 0, that is m cube minus m square minus 6m is equal to 0. So I'm taking out m outside, m square minus 1 minus 6. So this is m minus 6 is equal to 0. So m0 is the one root of the equation, and other factor is m square minus m minus 6 is equal to 0. Now write the factors. M square minus 3m plus 2m. Minus 3m plus 2m is minus m, and minus 3m plus 2m is minus 6m square. Minus 6 is equal to 0. Or m into m minus 3 plus 2 into m minus 3 is equal to 0. So what are the roots of the equation? Minus 2 comma 3. M plus 2, m minus 3 is equal to 0. Therefore, the complementary function yc is equal to c1 e power minus 2x plus c2 e power 3x. So this is the complementary function or yc of the given problem. The roots are real and distinct. The complementary function will be in the form c1 e power minus 2x plus c2 e power 3x. Now find the particular integral. So what is yp here? Yp or particular integral is 1 by d cube. I can write it as d into d square. I can write it as d into d plus 2 of d minus 3 also I can write. Or I can write d into, what I can write here, d square minus d, 1 by d on taking outside, we'll get d square minus d minus 6 of the function x square plus 1. So just I have written in factor form. On taking out d outside, d square minus d minus 6 of y is equal to this function, or yp is equal to 1 by d into d square minus d minus 6 of x square plus 1. So this is equal to 1 by d of, so you can take out minus 6 also outside. On taking out minus 6 or plus 6, whatever it is, on taking out minus 6, 1 minus. So what you will get here? D minus d square by 6 of x square plus 1. I think, so see this. So the first term minus 6d is one term, plus 6d square by 6 plus d square, 6. So what I can write, 6d on taking outside, minus 6 on taking outside, 1 minus d square minus d by 6, minus 6 on taking outside. So here I will rewrite. On expanding, you will get minus 6d, so the complete function, plus 6d square by 6, first term, 6d square plus minus minus plus minus 6d cube by 6. So what will be the term? This is minus 6d plus d square minus d cube. So this is not the term, d cube minus on taking outside, d cube minus d square. So just I will manipulate this. 1 by d, 6 also take outside, minus 6 also. Then what you will get? Or you can write here d cube minus d square minus 6d. Am I right? So just you write as it is the function. Then take minus 6d, 1 minus 6d and take outside plus 1, that is 1. Here what you will get? Minus d cube minus d square by 6d. Am I right? Minus 6d first term, minus minus plus, 6d cancel, so this is plus, minus 6d cancel, minus d. So this will be minus d cube by 6d minus 6d plus d cube and plus minus 6d minus d square of x square plus 1. Just taking out the term, that is the only thing, no problem. Minus 1 by 6d into, so I can write it as 1 minus, so what is the term? D cube by 6d, that is d square by 6 first term, second term d by 6, am I right? Whole power minus 1 of the function x square plus 1. So finally I would like to write the form either 1 plus x whole power minus 1 or 1 minus x whole power minus 1, 1 minus x whole power minus 2, like that you have to write. So by taking minus 6d outside, it is possible to write in the form 1 minus function of d whole power minus 1 of x square plus 1. Now expand this series. So minus 1 by 6d of what is the function? On expanding you will get 1, both are, this is minus and this is also minus. You will get all positive terms. 1 plus d square by 6 minus d by 6, and then minus plus 1 plus x plus 2x, 2x square. What will get? 2 into 1 minus d whole power minus 1. 1 plus x square. What is x square? D square by 6 minus d by 6 whole square plus so on of the function x square plus 1. So in expanding 1 minus x whole power minus 1, 1 plus x square plus x cube plus so on. So here x is d square by 6 minus d by 6. It is 1 by d. So in expanding, you'll get the term of the form. This I can write 1 by. So I can write here. So what I can write here? Minus 1 by 6d of the first term 1 plus d square by 6 is there, minus d by 6 is there, plus d power 4 by 36. That you can eliminate, not required. Plus d square by 36, that is required. D square by 36, because x square plus 1 is the term. A square plus b square, d square by plus 36, minus 2ab. So that will d cube term, that will not consider. Again, you will have the term d square by 6 minus d by 6 whole cube. That also not required, of the function x square plus 1. So this is equal to minus 1 by 6d into 1 minus d by 6. 1 minus d by 6. D square by 6 plus d square by 36. So what is the value? LCM 36. So 6d square plus d square. So this is 7d square by 36 plus 7d square by 36 of x square plus 1. Am I right? LCM 36, 6d square plus d square, 7d square by 36. Now on multiplying each term with 1 by 6d. So if possible, I can write d cube term also. Here I can write d square by 6 minus d by 6 whole square. So then next term, d square by 6 minus d by 6 whole cube also. D square by 6 minus d by 6 whole cube also. That also will come as the next term, d square by 6 minus d by 6 whole cube also. So in that you will get, so here you have to consider the d cube term also, because it is d. 1 by d means on cancelling out you will get the d square term also. So I will consider d cube term also. Just you wait here. Just I will show that what is the d cube terms we will get in the series. That I will calculate and I will write directly. So here 1 plus d, in this you don't get any term. In this you will get minus 2d cube 236. Am I right? So a square plus b square minus 2ab, 2 into a into b, 2 into d square into d, 2d cube by 36 with minus sign. Similarly, the expansion d square by 6 minus d by 6 whole cube, we'll get one term a cube minus b cube. What is minus b cube term? A cube minus b cube is minus d cube by 6 6 are 36 6 are 36 6 are what is 6 6 are 36 216. So you'll get 216 also. Am I right? D cube, a cube plus b cube minus 3ab into a plus b. You have to use the formula. So here on expanding you'll get d cube by 36 into 6. That is d cube by 216. This also will get. So the LCM is 216. 36 6s, 6 2's minus 12d cube and minus d cube. What is the minus 13d cube by 216? So that also will come. So that I will write here minus 13 by 13d cube, 13d cube by 216 of x square plus 1. Now operate each term with 1 by 6d with a negative sign, or minus, just put outside 1 by 6d and operating 1 by 6d first term. So here dd cancel, the value will be 1 by 36 only, and third term minus already taken outside 6d. So 6dd cancel, 7d by 216. 6 7 as it is, 7 by 6 into 36. That is 216, d cancel, d square cancel with the d. And here the last term 13d cube. So 13 d cube means d square by 216 into 6 of x square plus 1. So that is the final figure of the expansion of d. So now substituting 1 by 6 of d of this one, that means what? X cube by 3 plus 1 by d of 1 means that is x. Integral 1 dx, that is x. Next minus 1 by 36 into x square plus 1, that is the second term, plus 7 by 216 of d of this one, that is 2x, 1 derivative 0, minus 13 by 216 into 6 of d square of this one, that is equal to 2. So which will be the required particular, on simplifying, you'll get the particular integral of this given differential equation. Then the y is equal to the complementary function plus particular integral is the required solution. Here there is a little bit, you can write here 1 by d of d square, that also you can write. You can do as simple as possible. Here I have taken minus 6d outside. On taking minus 6d outside, it is 1 minus d cube minus d square by 6d whole power minus 1 on the writing in the numerator of x square plus 1. Right. So it is in the form 1 minus x whole power minus 1. That is 1 plus x plus 2x, 1 plus x plus x square plus so on. On expanding, you need to consider up to d power k term. It is x power k means you have to consider d square term, so that the value will consider up to d cube term, because it is 1 by 6d also there. So up to d cube, if you consider on cancelling out, you will get up to the term containing d square. So on operating each term, you will get the yp. On simplifying, this will be the yp of the given problem. So the solution will be the complementary function and particular integral is the required solution. So in this way, we can solve the problems when the right side function is on the form x power k. So if it is 1, you can separately, you can do the separate also, or you can do like this also. So in this way, you can solve the differential equations when the given function right side is x power k plus some other function. So there ends the 3 types to find the particular integrals when the right side functions are e power ax, next model sin bx or cos bx, and other one is x power k model. So with these few words, I conclude my session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.